So hi guys, we just wanted to show you some more stuff on the drift car. So actually Ozan is already doing a lot of fab work to the car itself. I showed already in another video about some specs about the engine, but I will get to that later in the video. So probably this will be a two-part video. So first thing, I just want to talk about the cooling situation or the cooling side. So like you mentioned, in the front of the engine we do not have a lot of space for the radiator, and we have a drift car, so airflow special for the radiator is a problem. So we decided to move the radiator in the back of the car. So we just have it sitting in the trunk, and let us lift a bit the car. So our idea is the air comes from the hardtop directly to the radiator. We will have here a completely ducting, so this is all ducted and pushed to the radiator, and the air just goes out to this point, to the rear of the car. We have not decided where we go with the exhaust. The first plan was to go to the front, to the side, but in European the noise things also for drift cars getting a bit difficult, so we just have to find a way here that everything is working also with the noise, but I'm pretty confident that we will manage that. So what we did actually to the car, everything here in the back is all cutted and all back welded in. So the underneath the car, which we can see, here's everything let's say cleaned or pretty tidy. We have here the point to hook up the car when you want to change tires, which is a pretty big deal on a drift car. And yeah, so this is like a universal Mishimoto radiator, and like mentioned, the air goes through here. Yeah, we also have in the trunk, we just cannot see that well, so probably Sebastian just can have a little look into the side here. So there are two pumps, Bosch 044. We are going with two pumps in one line straight to the front, so this is the catch tank system. Our coolant reservoir is there in the side, and then we're just going with the lines, or we just stay before we talk about the fuel system. Let's talk first about the cooling side. So we have here the radiator like mentioned, then we go on this side. Oh, let's turn around. Okay, so we are going here with the coolant line through the inside of the car. This will be also mocked up into aluminium part, and then we are just going up here to the front, and here in the front we have a electronic water pump, which is I think doing 305 liters per minute, so the biggest one which we could get, because yeah, cooling is pretty important, especially on a turbo car. So then we are just going on the back side of the firewall, we'll cut two more holes into it, and we just connect it to the parts where we want to, that we just can directly connect it to the engine, because we do not have to get in front like on other cars, because we have no radiator here. So this is basically the cooling system. I think at the end of the day we will have about, let me think, I think 12 or 14 liters of cooling capacity, which is the big plus point on this side, because more water takes longer to warm up, etc, etc, etc. So better cooling side, and it's also pressurized, so like we did it on the other turbo cars, pressurized cooling systems do have a lot of gain special when you want to keep the coolant temperature stable. So yeah, this is actually the cooling side. So now we just get back to the fuel side. So we are running the stock fuel tank right up here, connecting to dash lines through here up to this point, like mentioned. So here we can see the pump. We are going to two Bosch 044 pumps, like told previously. Then we are going from this side into a filter, which is located here, going down here, connecting back here, going through also passenger side. This will be also mocked up completely with aluminium panel. To the front, here sits the pressure regulator, and then we just go back to the engine. So this is actually the fuel setup. So a lot of people are asking why we are using a catch tank. Catch tank system is pretty easy. You have a lot of turning, you have a lot of moving, so the gas is also all the time swapping around in the tank. You just want to have one baffled part, or one part where there's enough gas, so we don't have any lean spots, or actually we don't want to have any problems with the acceleration of the car, to be safe. Power output will be something around 700 horsepower, and yeah, in the next point we will just get to the engine. So this is pretty interesting, what we did to the engine, how we built it up, etc, etc. Sadly it's closed up. Probably we have some pictures which Sebastian can show of the closed stack conversion, etc, but I will just talk through it, and we'll get through all the little points, and we will just talk about the whole idea. But before that, I just want to talk about the electronics, because this is probably something interesting for the guys in England, for the guys in Sweden or wherever. Like you know, one really good friend of mine is Dimi from MS Labs. So like always in our builds, we're using an MS ECU. We use some part of the stock wiring special for the body. So the whole car is completely new, wired up in our house. So front lights, rear lights, all that stuff, some relay stuff is located here to this part where the stock fuse box is. And then we have some more fuses which we use for engine dash, engine sensors, start button, spark, injection, ECU, and CSO is the water pump. And like mentioned also here we have some more from wiper, horn, etc. So all the stuff which is dropped here down to the middle part, here turn on the ignition, here turn on the fuel. We just wanted to make sure we could run the fueling, the heater and the cooling, all that stuff through the ECU, but special fuel I would like to have in a race car on its own switch. Heater is just for the interior, for the Reclamor, so we're running electronic heater. And the cooling side is when you just, the electronic water pump is regulated through a PWM table in the ECU, and will be also, so when the car is sitting you just can use this one, otherwise you can, the ECU controls the whole part of the cooling temperature. We were asked what we say engine is stable in the cooling side, so I all the time recommend 85 degrees in water to 92 and something around 100 degrees in oil, then everything is safe. So we did all the wiring by ourselves, also in house, like we did from the chassis. So this is actually a Deutsch connector which connects directly to the firewall. You just click this one off, take this one off, and you can remove the whole engine out of the engine bay without losing one part of the, or without disconnecting one part of the engine loom. So on the engine side itself, we are running NW or NGK coils from R8. Everything, fuel, water, engine, water temperature, oil pressure, gearbox temperature, and also differential temperature is always controlled also by the ECU. So a lot of wiring going back into the ECU, which is MS3 basic. We will talk about the MS3 ECU in a different video, but then I will just show how we set it up and on which tables we are using. We have all that part which goes to the engine and then back later to the dashboard. We will talk about the dashboard in, let's say, in 5 minutes, so when we are through here. We are using one N75 from VW as a boost control, or as a perch valve, let's say it like this. The boost control runs through that one, and we control the turbo. So this is basically it. So we just run a crank trigger on that car. We do not run camshaft sensor, because this is nearly impossible because we don't have enough space, and we have to use then in this case here on the back. We would normally, I wanted to use a MX-5 and A and B original sensor, but we cannot connect it because the camshaft is too far in, which is pretty sad. But then we just run with the crank on the bottom, which for a competition car should be not any problem. So yeah, let's talk about the engine. Or just we get through the dashboard. So we have all the information from the car, like oil temperature side, we have water temperature, we have gearbox temperature, we have differential temperatures, and all that stuff goes into the ECU so that the driver of the car does not have to switch off when everything is a problem. So what we will do, we have a race to dash dashboard up here, where you can see all the stuff. You can see the temperatures, you can see the pressures, you can see the problems. And actually when the car got a problem, it's got its own fail-safe mode. So when fuel pressure is dropping, or when the car is not running on all cylinders, or the NOx sensor is tipping on, it's all the time flashing on the dashboard with the message what the problem is. So let's say oil temperature too high, the car will just flash it, and after let's say 10 seconds of using still the car, it will not shut off. It depends on, so on a high oil temperature it will not shut off, on a high water temperature it will not shut off, on a high gearbox temperature or differential temperature it will not shut off. It just will quit the ref limiter and will just move it, let's say, to 4,000 RPM, so the customer or the driver gets attention of that there is a problem. But let's say when the AFR is going lean, we are using an Afr Safety Table in race cars, which means on 1.8 bar of boost we want to see 11.5 AFR. If that's not reaching the target and we have a difference in that case, it will shut off completely, because that could damage the engine or whatever. And this means, okay, directly full shut off, and then it will flash through the dashboard what the problem is, and will also be recognized into the ECU. So this is just something like on that project, for my opinion, pretty important, because we are not always with the car. With our own race cars, it's a bit different, because what we can see there is that we have the possibility to go all the time with the drivers to the racetrack. But with that cars it's nearly impossible, because the customer is probably in France or in Sweden or wherever, and give us a call and say, hey Jan, I just have a problem with the car, what can we do to find a solution for that problem? And then I can say, okay, do this or do this or do this, or tell me the message which is there, and then it's pretty easy. All the time when the customer gets such a build like this, he will get a shortly introduction about the software for the ECU, that he will have his own laptop on the track, so we can do some support, probably remotely or whatever. Hopefully, fingers crossed, it would never happen, but it can. So, so this is for that side. I think we are pretty confident that everything is finally controlled. All the internal communication from the dashboards to the ECU is done by Cambus. Yeah. So this is the electronic side. So now we go back more to the mechanical side of the engine. So what we have here is a 2.5 liter KL engine out of a Cedo 6. OEM horsepower is something like 160 horsepower natural aspired. We changed the following parts. So we are running a completely ARP stud kit. So the mains and also the hats are ARP. The hats at all are completely pre-printed, so which means the intake and exhaust runners are a little bit matched. They are not completely fine-tuned, because it's a boosted car. We think it's not that necessary, and so we keep the hats just, they are just a bit ported, and that's it. We're running different cams. We're running cat cams in the cylinder head with stiffer springs and different top retainers, because the top retainers like to fail on KL engines. Yeah, we are running adjustable cam gears. You cannot see them at the moment, or you cannot see them anymore because they are behind that closed up part. Customers were asking why we do not keep them open. On a race car, I do not like that, because when it runs out of the track, it could come something like a stone or whatever into the timing belt, and we could cause an engine damage. The bottom of the engine is probably the more interesting part. The whole sump is completely gutted and baffled, so we can make sure that we will have no problems, that the oil is going out of the oil pan. And we have Wiseco 8.5 to 1 compression pistons in the first oversize, running K1 rods, Toga main and rod bearings, 3-layer, and we're running a boundary stage 2 pump in front. We are running from Crab Engineering in England, we're running the timing wheel. And the coolest part on the engine, we did a closed stack build. So we just open deck engine, probably you know how it looks like. So I can show you here on the engine what is an open deck engine. So this is an MX-5 ND engine, but this is open deck. So which means all these cylinder holes and lines, they are completely open. What we did to the KL engine, we took it to a machine shop, they machined everything out here, and then we have like a brill which will dropped on top of it, and you just put it onto the engine. So all this is then gutted, and which is pretty good, because when you're running a lot of boost, the stock seal will go like this, so like a balloon, and can be blowing off and can make damage, or even it can blow up actually. So when you're running a closed stack top, you have the biggest effort of it, you have more the block, you have a bigger block stabilization at all, so of the engine itself. So this is pretty cool, and I never saw a KL engine with this closed stack. So we just did this all in-house with our engineer. The head gaskets are both left and right side, are both completely original. There is no O-ring cut head gasket in it, because there was no. And hopefully, fingers crossed, it will work, but we will be something around 1.5 bar of boost. We're running a custom-made Gieselworks intake manifold, so Lennart built all that stuff for us. We just can look into it. I think probably Lennart got some pictures of it, pretty sure, so we can show them how he built it. But he got little trumpets into it and running into the engine. You're running 630 RX7 side flue injectors, so this is like OEM, but they are all manually wired on a Xedos or on a MX-6 or whatever. You have them normally tacked in one part, and the original ECU just drops fuel per bank, and we can manage the fuel manually from bank to bank. What we have also, we have all that stuff is custom made. Everything is made by Lennart. So this will not stay like this is so close. There will be another part which locks that off. And but the headers are made custom, runs to the front, then to a GTW 3874 turbo from Garrett. Pretty old school, old style type, but it's pretty big. So yeah, it's like, you know, when you are in boost and you are in the drift, you will not have the problems that you are searching for spool or whatever, which is a pretty good part. Running a 42, I think it's Turbo Smart Westgate. We're running a tile blow off. And yeah, this is basically the engine. So the engine is completely built. The transmission, probably pretty interesting. It was like an idea from Ronnie and mine to say we just want to use as much as possible as master parts, because we are using a RX-7 FD transmission with our own flywheel, which we made with TTV in England, which connects to a custom-made pop shaft, and then connects to a completely built RX-7 FC rear axle. Which is also completely built, running a case differential in the back. So yeah, this is pretty solid. And the cool part is when the transmission will give up, I think we will go over to a sequential one, but just Ronnie have to learn to drive with this car. We will not go to the first level of boost. It will something like 500 horsepower. We will not raise it directly to 750, because I think it's a bit too much for the customer. Yeah, on that side. So let's talk about the axles. So what we did to the axles, actually, we have you're running 10.5 to 17 or something like this wheels, or 10 to 17 wheels or 9.5, so it's pretty wide. We have that carbon Miata wide body kit. I'm not the biggest fan of the kit, tell you actually, because it's not matching the look of the cars which I like. You probably know my green MX-5, so I like the cars more clean, not so not so extreme. But I think on a build like that, it matches the idea. So what we have, we running the stock rear axle completely, run the upper and lower wishbone also stock. We are running energy suspension bushings. We're running a special made drift suspension from K-Sport, and we're running a big brake kit also for drift, a special one for drift, so that the hand brake and the foot brake is on a different cylinder, so it's not pushing against each other. So when you are pushing the floor, the foot to the floor, it will brake the same when you also pushing the handbrake. So this is on the rear end, and the inner part is just a bit like custom built to fit in the RX-7 FC transmission. The FD transmission will be mounted to these 2 points. We are running no PPF in the car. I think we will have some little vibrations in the car, but I do not think that this will be a really big problem. We can do some alignment stuff, and yeah, on a drift car you are not that fast. So let's say you just rev it one time to 180 and then you're just drifting. But we will look for a perfectly balanced pop shaft, and I think that will be good to go. So let's talk about the front. We are running a completely IRP front angle or wide angle front kit. So all that yellow parts is not fabricated in-house. This is just a finished part from ARP. So we have a massive way of lock what we can do, as you can see here. So, and it goes more. At the moment it's just we have no steering rack in the front. I will just talk about the steering side later on. We can, and it can move more, but we have to do some cuttings here. Probably we have to change the wheels in the front, but not sure for that. So this is pretty cool on that side. And yeah, so this is actually the front angle, or the way the front is built. And yeah, let's talk more about the steering. So we are running a NA steering column, which is built without power steering. The problem on this side was we have no space to run a power steering. But the thing is, when you want to drift, you have a lot of turning on the wheel, you need a lot of force and a power on the wheel. So our idea on this side was we just want to have enough space in the engine bay, which we can do when we're running a depowered power steering. But what we will do, this is the part where there is no, the steering shaft is not topped in, because it will get electronic steering rack from a Citroën whatever, and built with 2 universal parts, welded to the body, to the car. So this is actually the way how we then have back electronic power steering in the car. And we have enough space in the engine bay. So this is actually the point of the the way how it turns, etc. Let's talk about the frame or the cage. So what we did, we chopped the whole car in let's say 10,000 parts, and then we said, okay, we cut everything away which we do not need. We wanted to have that NASCAR style door bars to have more space into the inside. We wanted to have an X which is standing out, so we cutted all this part in the back and lifted this back about 10 or 12 centimeters. Then we dropped in the X, we made the whole interior cage, went as far as back as we can to the mounting points of the suspension, which is here, and then we're also tubing the whole part to the front, where we cutted all the original panels which are here, mounted here, a welding point back on, going back up with the cage to this point, have another tube which runs up here underneath the OEM fender, turns around here in the front. We had to cut the lights, so sorry for that, but yeah, it will not be a street legal car. Going over the tube all around here, going back up here, connect back down here. And the coolest part on all that stuff is when you are removing this screws and removing that screws, you can take the whole front in one part away, so which is pretty cool when you have any problems. And we have a little crash bar up here in the front that everything works like it should be when you have a contact to a door bar, contact to a different drifter or a wall or whatever. So, and this connects back to the cage. Yeah, so this is basically one of the craziest builds which we are actually doing at the moment. It's sitting for a pretty long time here, just have to tell you. Ronnie and me are friends, so it's not the biggest deal, but the biggest problem actually, he was really fucked up by Corona. So we had 3 companies working on the car, doing parts for us, which were get bankrupt. And so the project was sitting, we were discussing what we will do. And then, yeah, Ronnie bought a cheap MX-5 just to learn a bit more drifting. And that we will just get the Black Beast ready for this year, and now Ozan is making the build. So like you mentioned in all the talking what we did, there is done a massive of work, and there will be also done more and more work. So this will be also a project where we focus on the next 3 or 4 weeks until it will be finished. And I'm pretty confident when we fire it up, because I think the sound will be amazing of a V6 single turbo. Special DKL engines, they really sound nicely. Thank you for watching all the videos. I think there are 2 parts of it. I don't know how long is it?
About 25.
Okay, so this could be 1 part. So you know now the idea behind the car, you know what we did, all the stuff that we made in-house. If you have any questions, just drop it in the link below and click abo for our channel. That would make us really happy when you want to see more of that crazy builds. See you in the next video. Bye.